So in this video I'm going to show you how to export the data from this NDVI image. This is an NDVI subset chip image for Salford, and so it's a one layer image where the brightness in each pixel represents the NDVI value. So white areas are going to have NDVI values of 0.8 or higher, and the dark areas are going to have NDVI values close to 0. And the grey areas NDVI values in between. We can have a look at the data or the histogram for these data by clicking on metadata and then clicking the information icon, and then by selecting the histogram. And so you can see the histogram here has got some values at this end round about the expected range from 0, which is about here, up to about up to 1. But it's also got some odd low values. In this in the box here, you can also see the values, which are the averages for the image. So we've got a maximum, mean, median, and mode, and standard deviation. So these are the data that you would want to use in your project work. But in order to analyze the data a bit more carefully, we can export the data to another program. So what I'm going to do is export all these values to a text file. So we simply select Manage Data, Pixels to ASCII, select the input image file, which in our case is Salford NDVI, which is this one here. And add that to the files to export, and we're going to call it SALF1, SALF1, and export that data to our OneDrive in this case. So that's done. So what we can do now is switch to Matlab. So this is Matlab now, and we should be able to find SALF1 ASCII here, so it's just here on the left hand side. So you need to identify where the file's located, and now we can read it into Matlab. So what we're going to do is to select import data and then identify the file SALF1 ASCII. So it's this one here, and click open. And then it will ask us to allow us to import these data. So on this dialog box, we want to select just the column, the third column, and we want to select from row 4 onwards. We then need to change the output type to numeric matrix, and we want to select exclude rows with unimportable data. And then we can import the selection. So just to explain that a little bit more, the third row where it says NaN means not a number, and these are the pixel locations with no data. So they're the black areas surrounding the NDVI image that we saw before. Also in this table you can see there are two initial columns, X and Y. They're the X coordinate and the Y coordinate of each pixel. So the X coordinate is the easting in Ordnance Survey Grid coordinates, and the Y is the northing in Ordnance Survey Grid coordinates. And the third column contains our data, but the first several thousand entries are not a number because they represent the black area around the image. We'll have a look at the data in a second, so let's just wait for the data to be read into Matlab. So now you can see the data are read into Matlab here in the workspace. It says SALF1, and so we've got 108,992 pixel values. We can close this box here, the import box, and we can now have a look at the data. So if we just double click on SALF1, you can see the numbers here. So this is the first pixel value, has an NDVI value of 0.5, 0.86, 0.78, etc. If we want to see the histogram of these data, we just type hist solf1 and press semicolon and press enter. And as you can see, we've got a histogram with a relatively small number of bars in it. And so what we can do is simply add the number of classes that we want to see in the histogram here. So now we've got a histogram that looks rather like the one that we saw before when we looked at the histogram in Erdas Imagine. So what we want to do is get rid of all the values which are less than 0. And so we're going to do a little bit of programming here to filter those values. So we set up an index command here. So we type idx equals find solf1 greater than 0 semicolon and press enter. And now you can see on the left hand side we've identified all the rows where the values are greater than 0. So there's 108,652 of them. So now we can make a new variable. So let's call it new, and we put the values in that we've found are greater than 0. So we say new solf1 idx colon bracket semicolon. So now we've got a new set of data with only values above 0. So if we now say hist new, we've got a histogram that looks like this. This hasn't got many classes in, so let's try 100 classes and see what the histogram looks like now. So now we've got a histogram with values greater than 0. We know that we can't have values greater than 1, and so what we can do is edit the histogram a little bit. So if we go edit figure properties, sorry, no, not figure properties, we go edit axes properties, and we can change the plotting range. So here we've got the values from 0 to 0.5, and under rulers the x limits we change that to 1, and there we've got histograms from 0 NDVI to 1. We can insert a label, so the x label is NDVI, and we can insert a y label, which is frequency, and so we've got a nice figure here. And you can cut and paste these, use the snipping tool if you want to make a nice figure from them, or you can save the figure using file save as, and then select a name and JPEG and save. So the other thing that we need to do then is extract the statistics. So if we want the median, we just simply type median new, and it'll print the value on the screen if we don't put the semicolon. So the median here is 0.5607. Similarly with the mean, we can calculate the mean in the same way, or the mode in the same way. So this allows you to manipulate the data, display the histograms, and export the figures and calculate the statistics. So hope that's useful, and